When I was at high school in year 11 and 12, I did quite a bit of science. I did chemistry, physics, and what we used to call 3-unit maths, because maths was my favourite topic. I actually always thought I might become a maths teacher. That obviously didn't come to be. But yeah, so I followed my love of maths more into computer sciences, and I ended up working in IT. Eventually, a few jobs later, I was working in IT for a company that installed computers on cruise ships, and I specialised in small expedition ships. So I went to places like the Galapagos Islands, Alaska, Europe, Costa Rica, Mexico. And while it was fun, I hated being trapped on board in a tiny little room working on the computers. And while I was working on some of these ships, I met a lot of the expedition leaders and sometimes scientists that would come on board. And I thought, right, I want to do that. So I went back to university with the intention of doing marine science, so I could get out on the ocean and go on ocean voyages and collect data and come back and show the world what I've discovered. Yeah, and that's kind of where I'm at now, doing my PhD in paleoclimate reconstructions of the Southern Ocean. And I've been on 3 Southern Ocean voyages so far, including one to Antarctica, which was amazing. And they're the samples I'm working on now for my PhD. So I originally started out studying in a department of statistics. Again, loving maths. When I went back to university, that was naturally where I went. However, I started doing units in climate science and in paleobiology. So I started looking at small microfossils found in marine sediments and using them to figure out what the climate was like in the past. So even though now I'm studying in a department of earth sciences, the work I do is very interdisciplinary, and you can be located in biology departments in some universities or the environmental science department, because earth, marine, climate science are so intertwined that you really need to know a little bit about everything to really understand the system as a whole.